This is chapter 5.2, Exponential Functions and Graph Notes, video 2. Again, if you are not watching this video on Edpuzzle, you are not getting credit for it. So be very careful that you're watching this through Edpuzzle only, not through YouTube. So compound interest is a very good example of exponential functions being used in real life. They use this in credit cards, in car loan debts. They use this in your savings account, although your interest is not very high. So there is a formula for compound interest, and it's A of t equals P times, in parentheses, 1 plus R over N to the N times T power. That looks very complicated, but it's not too hard as long as you remember what each thing means, which I will tell you in just a second. Make sure, if you want, you can go ahead and start making a note card for your next test and go ahead and put compound interest on it, the formula, and what each thing means. A of t means the amount in the account after a time. So after a certain time, that's the end amount, basically. P is what's called the principal. This is your initial amount. Initial amount that you're investing or putting into account. R is your rate. This is your percent that you always want to use as a decimal. And N is the number of times compounded per year. T is the number of years. If you look at number 4 right here, it says compounded daily. So you need to know how many times per year that is. So if it's compounded daily, that's 365 times a year. If it's compounded weekly, that's 52 times a year. If it's compounded monthly, that's 12 times a year. If it's compounded quarterly, that's 4 times a year. They'll also use semi-annually. That's twice a year, and then annually. And that's once a year. So make sure you kind of know the difference between them. You should have heard these words before and been used to them, and how many days, weeks, and months are in a year. So let's go ahead and jump right into number 4. The hardest part of this is putting it into the calculator correctly. So I need to find A of t, P, R, N, and T. So those are what we're looking for. Suppose $900 is invested at 7.3% interest compounded daily. How much money would be in the account after 2 years? So important information. $900 is invested in an account. So that's your initial amount. That's your principal. $900. 7.3% interest. That's your rate. But remember, you have to use this as a decimal. So 7.3%, you take your decimal, move it 2 places to the right, and add a 0. Your rate is 0.073. It says compounded daily. So that's our N. Daily is 365 times a year. How much money would be in the account after 2 years? Those are my important things there. So 2 years, T is 2. So that means we're looking for A of T. So just plug it into the formula. A of T is equal to 900, open parentheses, 1 plus 0.073 divided by N, which is 365, to the 365 N times T, 2. All right, let's go ahead and put this in my calculator. So I have 900 times, open parentheses, 1 plus. Now you can do this using division or a fraction bar. Remember, to get the fraction bar, you do alpha y equals 1 gives you the fraction bar. 0.073 divided by 365. Now make sure you arrow out to close the parentheses. And this is all to the 365 times 2. Make sure that times 2 is also in the exponent. If you have problems putting this in your calculator, let me know. Hit enter. This is your answer. So after 2 years doing nothing, there's $1,041.46. Always round to the nearest cent. That's 2 decimal places. So this is equal to $1,041.46. That's how much money would be in the account after 2 years, doing absolutely nothing at 7.3% interest. That's what's so great about compound interest. So suppose $6,250 is invested at 6.75% interest. It's a little bit tricky. Compounded annually, how much money would be in the account after 6.5 years? So again, I'm going to go ahead and list my variables over here. This is what our initial amount is, $6,250. So that's our principal. It says 6.75%. Remember, we first of all need to make that into a decimal, but 6.75. Remember, 3/4 is just like 75 cents. So this is 6.75%. Again, take that, move your decimal to the right twice, so it's 0.0675. Compounded annually. Annually is 1 time a year, so N is 1. It says how much money would be in the account after 6.5 years. So you can use 6.5, or the easier thing to use is 6.5. So plugging that into the calculator, that'll be A of T equals 6,250 times 1 plus your rate 0.0675 over N, which is 1, all to the NT. So this is 1 times 6.5. Again, I'm just plugging it into that compound interest formula that comes from up here. Now, let's go ahead and put this in our calculator. So we have 6,250 times 1 plus, you can put your fraction bar like we did last time using alpha y equals, or you can do 0.0625 divided by 1. That will work as well. Oh, and it's 0.0675. Let's change that. Close. Then raised to the 1 times 6.5. Enter. This gives us $9,555.89. You don't have to round on this one, but be careful. Remember, if this 2 was a 5 or higher, you would have to round it up. So this is equal to $9,555.89. So again, $6,000. You don't touch it for 6.5 years. And you get an extra $3,000 basically. It's pretty amazing what interest does for you. So the last one is your turn. See if you can do this one on your own. Choose the correct answer from the multiple choice and Edpuzzle, and then I'll put a link in case you get it wrong.